Hello everybody. Today I'm going to be walking you guys through creating a new feature script basically. So I've been writing feature scripts for a long time, although I haven't actually done that much as of late. And I've been kind of wanting to share some of the feature script knowledge I've acquired over the years. Since FeatureScript was my first programming language, this is actually I actually learned programming from the FeatureScript documentation, which I would not really recommend because that's not really what it's for. It's more for if you already have programming experience, getting into FeatureScript specifically. But having gone through that, I know what it's like, starting out for the first time. And so I thought, maybe I could write a new feature and kind of talk you guys through it as I'm developing it. Maybe that gives me something a little to do, a little more fun for me that way. And maybe, you guys learn something. So without further ado, we're going to get right into it. So I'm in my backend document. I have a bunch of feature scripts in here. This is actually a new feature I've been wanting to write for a little while. So this is going to be useful. And I'm going to start simple and, over the course of multiple videos, maybe I'll, we'll slowly build it out. So this is going to be a robot bearing hat feature script. So basically in robotics, we have bearings that sit in plates. The bearings typically have a flange. And so one of the things we want to do is prevent that bearing from popping out. And so sponsors or various vendors sell these bearing hats, and they just sit over the bearing, capture the flange, keep it from popping out. You screw it in, and so we're going to try to cut the holes and maybe cut the bearing hole as well. So it's a little bit easier to use these. So the first thing is we're going to want, so the first thing I always like to do is I like to look at existing UI. So I just know from experience, looking at the UI, right, the first thing we're going to want is we're going to want a query parameter so that users can select where they want to put them. And in this case, we'll take a bearing. And so I'm actually going to base this off of the whole feature, right? Because the whole feature, so if I just make a quick example part here, Humpty Dum, right? Sorry, I didn't come very prepared. So extrude this, right? So if we look at the whole feature, right, you can see this sketch points to place holes, right? It works very similarly to what we're doing, where you are taking a directional input, right? And then you can also have the mate connector if you want a little more control. So we're going to go ahead and actually try to steal that a little bit, right? And so here I find it's very helpful to look at the Onshape standard library because all the source code is very public. And so I know the feature is named whole.fs. So there's a bunch of code in any standard library feature, right? They have tons of documentation. You can actually see here, they have, this is the feature version. So a while back, they actually redid the whole feature pretty majorly. But because they have to preserve backwards compatibility, any old whole feature still has to work. So they actually have a bunch of hidden parameters in here that are the old feature, interwoven with the new parameters. And then they have a bunch of code to reconcile that. But this part here is what we want, right? So we can see if we ignore the old non-V2 stuff, these are all hidden parameters, right? We can see unit system and style, right? And if we look at the actual whole feature, right? Unit system, intermetric, style, simple counterport countersync, right? And then we can see that this next parameter here, definition allocation, is the one we want, right? So I'm actually going to steal this, and I guess I'll also steal the scope while I'm here as well, because there's useful filters there. So I'll go ahead and copy paste those guys in, right? And so I'll just go ahead and commit that. And now if I add my feature, robot bearing hat, right? So we can see we have a UI very similar to the Onshape hole feature. All right, I can select my holes and I can select a merge scope. So I like that part. It's always good, anytime you're writing features, to think about how you want to, anytime you can take inspiration from existing features, even if you're not copying and pasting the parameters directly, it's helpful. And so looking at these, right, there's a bunch of code here, right, but we can see this takes sketch vertices that are modifiable, right? Modifiable entity typically refers to edited in context, right? So if I open a Part Studio in context of an assembly, that puts ghost references to that assembly in my Part Studio, right? And those ghost references are actually selectable by default, right? So if I have, so if I didn't have this filter on here, right, I would be able to like, if there was a sketch that I inserted in context, right, I would be able to select sketch points from that. So this filter requires it basically prevents like in context ghosts, and there might be some other edge cases too that it also prevents, but it kind of guarantees that whatever you're selecting is like from the current Part Studio, and was like earlier in the feature tree as opposed to like derived or something. And then body type make connector. So when you have this as a filter, it actually causes the query parameter to generate this select make connectors button. So you can also select make connectors as well. Yeah, so I'm just gonna tweak this a little bit. So I'll just update this to be hats because this is the bearing hat feature, not the whole feature. But yeah, so that's my basic selection, and then merge scope is also fine. We see it takes bodies that are solid, right? So just bodies could be like make connectors and things even. Solid requires it to be like a physical part. Modifiable to print entities, and then this does actually allow meshes, which I don't think I want. Because I don't really think people should be adding bearing hats to meshes, although that's very much a use case and it really doesn't matter. Yeah, so we'll do that. Let's see here, and then I need to think about, I guess that's probably everything I need from the UI to begin with. And then obviously I'll have to go back and add additional features as well later on, but I think this will get us started. So the first thing I'm going to want to do is I'm going to use this function, verify non-empty query. This is a very useful function. Basically, you can use it to mark a query as required, right? So parameter name is going to be the string name of whatever parameter you want to check. So in this case, my query is named location, so I'm going to pass that. And then I can pass an error, right? If you read the documentation, it says by convention to take the form select parameter display name. Right, so they say like select entities to use, and so I'm gonna do something very similar, right? Select sketch, select sketch points to use, right? And I think I could actually, if I wanted to get extra fancy, let me see here. Yeah, so you can see by default, right, it says no whole point selected. And actually, I do like that error a little bit better. So I am actually going to use that. So the way you can use Onshape string enums is you can type out error string enum. It's marked as hidden, so it won't like autocomplete until you type it all out. And I believe that's called whole no points. And so if we open that, right, we can see STD can take a little while to load sometimes. Yeah, so if we search for it, right, so they have all the error messages here as well, right? So if you ever want to find, a specific error message that you like from the Onshape standard library, so like here, for example, right, I can see no whole point selected, right? You can always come into error string enum gen.fs, right, and just, search whatever message you want. And I think the other message I do want from this as well is when there's no merge scope, right? It says no target part selected for whole. That's a little less helpful, I think, for me. Well, I might use that too, actually. But I think we're getting a little ahead of ourselves here. But basically, so we can see like here, right, if I come in here, if I don't have my holes selected, right, then I get no whole points selected. And the other cool thing is it does highlight it in red as well. So if you just, like check the queries empty manually, you won't have that behavior. If we come in here and we actually look at the source code for verify non-empty query, right, this is maybe a little too technical. Actually, this is definitely too technical. Okay, and they have an internal. Yeah, so basically, it checks if it's a query, right? If it is a query, it evaluates it. If there's no result, if there is some result, it returns it. Otherwise, it throws an error. and also highlights the parameter name. Yeah, and so that's why it takes the parameter name as a string, so it can highlight it when it throws the region error, as opposed to just taking definition.locations, the query directly. Because obviously if it took the query directly, then you could just evaluate it immediately and verify if it's empty. But this way they can throw it back and highlight the parameter in red. Anyway, maybe a little bit too much. We'll keep going. So I will also go ahead and verify the scope. Actually, I won't, because I get the feeling I can get the error handling for the scope from a function later on. But yeah, so let's see here now. What is the best way to do this? So I think probably, yeah, so I have a bunch of error handling, right? They set the name template. Sheet metal parts prohibited. Yeah. Okay, there's a bunch of code here. Actually, let's just search whole no points. Yeah, so here we can see, oh, they're actually checking it themselves. That's funny. And they do some stuff to, I believe this filters out, yeah, this filters out duplicate holes. So if you select the same point twice, it filters it out. I'm not going to do that because my life is too short. Oops, I'm going to accidentally hit my back button on my mouse. Anyway, so definitely don't want to look too much at standard library features because you will get lost in the sauce a little bit. And they obviously have a ton of code in there. We don't need all of that. So right now I'm just going to focus very much on getting a basic implementation down, and then we'll go from there. So now I want to loop over locations and basically cut a bearing hole at each one. And so the way I'm going to do that is I'm actually going to use for each entity. Do I want to use for each entity here? I'm actually going to do it myself. Well, I guess I will use for each entity. So this takes a query, right? Actually, do I want for each entity? Okay, sure. I'll use for each entity. So basically what this does is it loops over a given query. So here I'm passing in my locations. And then it calls this callback for each one. And basically that allows you to do operations in it. So do I just... I actually need to sketch. Okay, I'm not going to do that. Yeah. So I'm going to do a standard for loop. And I do want to actually roll these up into whole locations. So I might do that first. So let's do planes equals evaluate. Okay, I'm going to map array. So another fun thing about verify non-empty query is it does return an array of evaluated queries. So I can go ahead and get the locations. And technically this is a little bit of a misnomer. These are actually the individual queries, right? And so now I can iterate over that. Locations. And here I can pass in a map function, right? So this is going to be a location, right? And we know each location is going to be a query. So I'll just go ahead and add that type hint as well for me, so my code is a little bit more readable. Wow, they do not have good formatting on the new arrow syntax. So I'm actually not going to use that because it looks kind of bad. Yeah, so I can loop over like this. Yeah, the difference there is there's this fancy syntax where you use an arrow instead of having the function keyword. So it's like JavaScript, but I didn't like the auto formatting. I use Format Feature Studio a lot. I would say anytime you shouldn't not use Format Feature Studio because you don't like the way it formats your code, because that means you have to format everything yourself, and that is miserable. So I say always use Format Feature Studio or format your code. And if you don't like what it's doing, deal with it basically, because it's not worth the hassle of fighting it all the time. Anyway, so yeah, so now I want to get the planes basically. So I'm going to use my own personal function here, actually. So I'm going to go ahead and add an import to utils. Yeah, my core utils. So this is basically my own personal library I have defined in this document. You obviously won't have it unless you copy my document, which you should probably not do. Oh, that's cool. That's new. Yeah. But I will evaluate. Yeah. So evaluate vertex chord system, right? So this is designed very similarly to evaluate vertex point from the standard library. I even did the same documentation. But basically all this does is it takes a query for a location. So in this case, a sketch point or a make connector, and it returns a coordinate system at that location. And I'm going to actually convert it to a plane. So I'm using the arrow function to inject whatever is here into the argument here. And then plane is just this is a constructor function you can see. So it creates a plane. And here we're using the chord system as an argument. So basically there's chord systems and planes. They're both functionally equivalent. It's just one has an origin and some other stuff. It's really just semantics, the difference. There's really no difference. They both have an origin, a normal, and an x. And they define like a right-hand coordinate system in 3D space. And these are geometrical planes, right? So these aren't like your sketch planes or like your construction planes in like your Part Studio. A plane is like it's an origin, an x, and a normal. That's just what it is. But yeah, so I'm going to return that here, right? So to summarize, right, we're taking our locations array returned by verify non-empty query, right? We're mapping over it. So for each location, we're evaluating the vertex coordinate system at that point, and then we're converting that coordinate system into a plane. And so if I print this now, or actually I'll debug it, which should show the planes in theory, right? Assuming I've done this correctly. Right, so now if I select points, and I'll open my notices, pull it up, yeah, so it's printing my planes. And if I debug a specific one, so I'll just access like the first one, right, it's overloaded to give it like a geometrical representation, right? So you can see whenever I click a sketch point, I'm getting, or whichever first one I click, right, I get that vertex point. And if I choose like a make connector or something, it evaluates that too, and you can see the coordinate system is the exact same one as the make connector you selected. Yeah, and the reason why we're going through the effort of evaluating the coordinate system and stuff as opposed to just like, because we could just use like evaluate vertex point, and that'll give us a point in space, right? But the problem is we also want a direction from this, because we not only need to know where the hole starts, or where they want the hat, but they also need to know what direction, because otherwise it could be any which way, and so this way we know precisely which way they want, right? So here, for example, when you click this point, right, not only do we know you want the hat here at this point in space, but we have this normal axis, so that tells us you want it cutting into the part, and so that's so that's the exact same thing that hole does, right? The hole feature, and we're taking advantage of it ourselves. And then to talk a little bit more about this, right? So this is a pretty simple function. It looks a little scary, but basically what's happening, right, is if we have a vertex, right, and I filter for the first entity just because there really shouldn't be more than one. So what's happening is we're taking whatever vertex you pass in, right? We're taking the first query of it, which it should be a single query, so that shouldn't do anything. And then we filter out anything that isn't a vertex, and we filter out anything that isn't a sketch object, right? So basically, this is checking if arg.vertex is a sketch vertex, right? And so if it is, right, so if after filtering out anything that isn't a vertex, anything that isn't a sketch object, right, if we still have, if we don't have a query at that point, then we know we do have a sketch vertex. The logic's a little confusing. But this is a pretty common pattern for like checking if a given query is something, right, matches a given set of filters. Because if it is, for example, if it's a solid part, right, or a mate connector in this case, would be what we would otherwise expect, right? So if it's a mate connector, then this will filter it out and the query will become empty. So this will return true, and this will return false, and this will invert it, and it'll become false. So we'll end up down here, right? And then we'll check if it's a mate connector. But this sort of pattern of if the query is not empty after I ran it through some filters, then I know that whatever filters I ran it through, it must be of that type, is pretty common. But basically, yeah, so we run it through those filters. If it's a sketch vertex, we grab the owner sketch plane, right? So that's why it has to be a sketch vertex specifically, because otherwise there's just any point, like a corner on a 3D part. That doesn't have a sketch plane, so that doesn't have a direction associated with it, right? It's just a point in 3D space. And so if you were trying to put a bearing hat at the location, it would be any arbitrary direction. We wouldn't have a direction associated with it. And then we set the origin of that plane to the center of the vertex point. Since the owner sketch plane of a given sketch entity doesn't have to actually be the center of that. And then we return a coordinate system around that plane. And then on the flip side, right, if it's a mate connector, we can just call evaluate mate connector, and that returns a coordinate system right away. So basically just wrapping those two functions into one. And so that's just a library. This is just a custom function I have in my own personal library that I keep and maintain. I personally think it would be useful in the Onshape standard library, but I don't work in Onshape, so anyway. But yeah, so I find it useful in cases like this. So we now have an array of planes, and so now we can loop over that array of planes, and go ahead and do stuff with them, right? And so here, right? Okay, so I think the next thing I want is a diagonal of the length of the part studio, right? And the reason for that is because I want to cut an arbitrarily deep hole. And the way you do arbitrarily deep things in Onshape, and actually in all modeling software, I'm pretty sure, is it's kind of a cool technique, right? So for example, right, if I were to do a through all extrude, right, so I say I want to do a cut through, right, oopsies, extrude that as well, right? So if I come back and I say I want to do a through all extrude, right, you'll notice my through all extrude isn't actually arbitrarily long, right? Something fun, right, is if I make this part bigger, right, you can see my through all extrude actually becomes bigger depending on how big my part is, right? So there's some interesting logic going on here. And so actually what that is, right, is the way Onshape calculates the length of things that need to be arbitrarily long, like a through all extrude or a hole that's going through everything, right, is it takes the bounding box around everything you've drawn in your part studio so far up to that point, right, and it takes the diagonal length of that. And the reason for that is, of course, because the diagonal length of a bounding box around a collection of stuff, right, is guaranteed to be longer, than any. It's guaranteed to go through all of that stuff, basically, right? If you think about it geometrically, hopefully you can kind of see how that makes sense. But yeah, so that's a pretty common technique, and so we're going to go ahead and emulate that. And so the way we're going to do that is I'm going to grab a bounding box using counts bounding box equals evaluate box 3D, right? My topology is going to be everything in the part studio that's a solid body. Actually, it can be my scope because I only have to cut through things in my merge scope, right? And it does not have to be tight. because it just has to be, arbitrarily large. Because this is arbitrarily large, it doesn't really matter. And then the length of that is going to be diagonal, box 3D diagonal length around my bounding box, right? So that's going to be the length of my bounding box, right? And then I can also be fancy and, and so since I am using my scope here, right, I will get an error if the user hasn't selected a scope. So I will go ahead and verify my scope is non-empty as well. And I'll do error string enum dot, I'll just say select a, select a body to cut, or select a part to cut. Right. Okay. So now I want to cut my actual bearing hole. Right. And so here, let's see here. How do I want to do this? I think I want to get, I guess I'll just sketch it out, right? Do I want to do transforms? Transform, extrude. Yeah, so there's a couple different ways you could do this, right? You could, I could use OP hole, right? This is relatively new. You basically give it like some hole profiles defining like what you're gonna cut. That being said, it's kind of massively overkill for something simple like this. It's really for like if you want to like make a hole going up to something or like through one part and up to another or things like that. There's a bunch of utilities for that. Because like OP hole doesn't even give you like the hole attributes that like make it a proper hole in Onshape's eyes. So like if you wanted, like if you really wanted a hole to like show up in like the hole table and stuff and like in drawings and like have all the proper attributes, you'd really have to call like the actual Onshape hole feature, which is this guy here, right? Also equivalent to this, right? OP hole is a simplified version of that. It's a little easier to use programmatically, but you don't have all of the clutter, right? All this random code checking all the things and whatnot. But you also don't have useful things sometimes like attribute setting and whatnot. The other alternative is you could sketch it yourself and extrude it, right? You could also sketch it, extrude it, and then transform it to all the locations. Trying to debate which one is better. I want to say you sketch it once, transform it, and then you boolean it after. Yeah, I think that's going to be the most robust. So I'm going to go ahead and do that. So basically what I'm going to do, right, to give a visual representation, right, so where's my origin at? Oh, it's really big because I was showing that. Okay. Let's make this small again. Okay, so basically, if we hide this and hide that, right, so what I'm going to do is I'm going to sketch a hole like this, right? And I'm going to make it the size of my bearing hole, which is 1.125, right? And then I'm going to extrude it down an arbitrary length, right? The diagonal length of the bounding box, so it'll be a through-wall extrude, basically, right? And then what I'm going to do, right, is I'm going to transform this, right? Or actually, I'm going to pattern copy it, right? So there's no like point pattern in standard Onshape, but you can imagine patterning it so that this becomes this point and this point and this point, all the points the user has selected, along their direction that they've selected, right? And then once I have all of those in place, all those copies, I'm going to cut all of the parts using that, and then I'm going to delete my extrude after. So that's basically the gist of it, right? Yeah, so we'll start out by sketching. So I'll go ahead and make a sketch, const pull tool equals sk, or new sketch on plane. You can also use new sketch. This one takes a query. This is what the sketch tool uses in Onshape, I believe. Actually, probably not. Yes, it does. Yeah, because it has disable and printing and those other options. We're going to use this new sketch on plane, which takes a 3D vector instead. Takes like the geometrical plane, right? So an origin and a normal, and an x direction, as opposed to like a query based one, which would be for like one of these planes, for example, right? So it's important to understand like when you're working with like the geometrical plane versus like a actual like query for a construction plane, which is going to be like something in the graphics window. And so here, right, to get the arbitrary plane, I know I can use the constant xy plane, which is just, if we see the documentation, right, it's just the world xy plane. And so that is the geometrical version of the xy plane, the geometrical version of the top plane, right? But not actually the top plane, right? You could do the top plane, the actual top plane. There is a query for that. Right, so this will give you the actual top plane in the Part Studio, and you can either get the plane itself or the face it represents. But we don't need to do that here. We can just use the geometrical one. Okay, I don't know why I called this whole tool, so this will be my sketch, right? And now I'm going to cut my circles, right? So I'll cut it into my sketch. This will be the center hole. The center will be there. I'll change this to meters just for, yeah, you can also, for zero vectors, you can do like 0 vector 2 times meter. It doesn't really matter. This just creates an array of size 2 filled with 0, and then you times it by meter. Note only 2 dimensions because sketches are 2-dimensional, right? And so we're going to be sketching about our center here. And my radius, right? So I'm going to do 1.125 times inch divided by 2, because it's radius. And so here, like, so anytime you define a constant in Onshape, right, you want to define the units with it. So here, 1.125, obviously 1.125 inches, right? And then because it is inches and not like meters or, degrees or number or whatever, right? I'm going to use whatever Onshape constant it is, right? And basically what it is, right? So if you actually look at the source code again, right? The way Onshape units are set up is actually pretty smart. Basically all units in Onshape are in some internal representation. So all lengths are internally meters, all angles are internally radians. And so what these are defined as, right? So you can see a meter is value 1, right? And then a centimeter is 0.01 meters, right? So these constants are simply, whatever a centimeter is in meters, right? Whatever an inch is in centimeters, which is, in meters, right? Whatever a millimeter is in meters. And so basically what that means is when you multiply by them, right? So when you take 1.125 times whatever an inch is in meters, right? The end result is the value as 1.125 in meters, right? And so that's why like printing values like that can be a little inconsistent, right? Because when you multiply by an inch, right, you're really converting this to whatever the value of 1.125 is in meters, right? So in this case, you get this number, right? And then you also have some fun floating point precision shenanigans going on as well, right? So we can see that is correct, right? But obviously that's not what we want. And so normally the way you get around that is, so like, rad equals 1.125 times inch, right? So if I wanted to actually see like whatever arbitrary value, the way you can do that is you can convert back by dividing to like whatever unit you want to see it in, right? So here, right, when I divide out, the units cancel, right? So this is no longer a length meter, it's just a number. And then when you divide by, whatever the value of inches is in meters, right, it cancels out, and so you get back to your 1.125. And so, and you can also, convert to whatever else you want to, right? So if I wanted to see it in centimeters, right, I can see that, right? And so that's a pretty handy way of, or that's generally what you have to do for like debugging units and whatnot. So that's a pretty important tip. But yeah, so we're going to sketch our circle there. And then I'm also going to sketch our 2 bearing holes, right? So I'm going to go ahead and do those now. Or sorry, our 2 mounting holes, right? So I'll do my left hole and my right hole. And here, the radius is going to be 0.201 times inch and 0.201 times inch. Eventually, I'll need to add an option to allow the user to choose fit as well, but we'll start with those for now. And then I'll do my center. And so if we look at the drawing for this part, I believe this is 2 inches center side to side. So I'll go ahead and do that. So 1, 0 times inch, right? And -1, 0 times inch, right? And then I'm going to go ahead and solve this sketch, right? Yeah. So if we run that now, so we should see our sketch. Yes, we do, right? And this looks a little wrong. Oh yeah, I forgot to divide by 2. That's right. But we can see that is correct. Yeah, and these are radius. So boop, boop, boop. Probably best practice to have the leading 0 for my own sanity. Okay, cool. And then I did mention I want fit. So let's go ahead and add that. So the way we're going to do that is we're going to declare an enum. So an enum is an option you can select from, right? So there's 2 parts. You need to have the actual enum you're going to select from, and then you need to have an enum parameter that exposes that enum to the user. So I'm going to start with my enum declaration up here. So I'm going to make a new enum. I'm going to call it whole fit. And then I know the syntax by heart because I've done this a lot. But you need anytime you use it in the name, you can give it an annotation so that it you have a value for your user. And then you can you have the actual values, right? So a baseline enum is like that, right? You know, you just an enum and then some common separate values, but we also add these annotations specifying a different name. And we do this, and you could also do this as well and not have the annotation, but to be compliant with the Onshape style, this is capital case, so like capital H, capital F, and then enum values are generally always all upper, all caps, and if they, you know, spaces are denoted by underscores. So I like to comply with that, but you don't have to if you really don't want to. And so we'll call this whole fit. And this might actually be more accurately, right, is whole fit. Oh yeah, and it has to be exported, so Onshape has access to it. Yeah, so this is a pretty standard way of doing it. And maybe we'll do this mounting whole fit, right? Okay, and then we'll go ahead and grab that fit as well, or we'll grab the actual radius. Equals, and I'm going to do a little bit of the forbidden art. So switches in Onshape are undocumented, but they're really good for stuff like this. Probably shouldn't be doing this in an introductory video, but whatever. Times inch, right, whole fit dot close is 0.196 times inch, right? And then I'm going to divide the result by 2 because it's radius and not diameter. So we'll do that, right? And then I'll substitute this in down here and down here, right? And there's a problem. Syntax, I left a 0. Yep, okay, ta-da. So format that and commit it. And now let's see what we got. Yeah, So we got our hole, and I can change between them, right? And our fit goes from close to free fit when we do that, right? And then a little bit of syntactic sugar, right? I'm going to add my UI hints, right? And so here I know I want a show label, which will add the words like mounting hole fit, or I guess I'll just be, yeah, mounting hole fit in line. And then I also want UI hint remember previous values, so that way when you use the feature again, it remembers what you had last time. So that's just like a quality of life thing. And generally most parameters where it makes sense, it also makes sense to do that as well. And because there's multiple, I need to have an array. Yeah. Okay. Ta-da. Yeah. So we can see here, if I don't have a merge scope selected, it complains. We did that a long time ago. And now I have my mounting hole fit there as well. And I can change between free and close. And let me just make sure, yeah, close is the default. I just want to make sure I'm being consistent. Oh, okay, I'll switch that around. For consistency's sake, may as well. Yeah, and then you can also specify a default if you wanted. By default, it takes the top one. But if you want a different default, you can just put whatever name you have here. So this way it would default to free. So if you create a new feature, you get free now instead of close. But I like close. That's fine. So I'm going to leave that. Okay, cool. So that's our sketch. So now I'm going to extrude it, right? So I'm going to use OP extrude. There's also extrude. So the difference is one has OP in the front and the other does not, obviously. But the actual difference is this extrude here, right? This is the actual Onshape extrude feature, right? So anytime you add an extrude to your part studio, this is that extrude feature, right? So you have solid, you have surface, you have thin, you can add, remove, intersect, right? You can set, a direction, a starting offset, draft, second end position. You can do all of that, right? Because the extrude feature, right, if we look at the documentation, right, it's actually an OP extrude wrapped in an OP boolean and an OP draft, right? Because the actual Onshape extrude feature supports all of those things, right? Not only can you extrude stuff, but you can boolean it to stuff after by adding, removing, or intersecting with something, right? You can also even add a draft to it, which is technically a separate feature. And so obviously we don't need all of that, right? We don't want all of that. I don't need a surface extrude. I don't need a thin extrude, right? I just need to, push some stuff in a direction. So I'm going to use OP extrude, which is much simpler, but more performant and has less of the overhead of all of that stuff that I don't need. Yeah. So then so then I will extrude, and so my sketch entities will be everything Q created by ID plus sketch. Actually, that's not quite right. I can use Q sketch region because it's a sketch specifically, right? I don't care about that because I don't have any inner loops, so I'll just use whatever's the default. And then my direction. So again, we're just extruding in a normal, so I can just use z direction, the global constant. And again, this is just a simple vector. So this is just like the math version. But as opposed to doing something goofy like you could do like evaluate axis and do like, I don't know. Yeah, I don't know. You could try doing like some query-based thing to end up with this, but you just need a basic vector, right? So this is, the vector 0, 0, 1 is my direction, and then extrude, and then I'll do the length, right? And then do I want to extrude in both directions? Yeah, so I could, so this produces this, right? I don't need this stuff. Yeah. Select a part. Okay. Yeah, so that produces that, which is pretty neat. I think I want the direction backwards, because typically when people select stuff, if you select like a mate connector on a part, the z-axis is by default facing outwards, right? So for example, if I select here, right? It's actually facing. Wait, is it arbitrary? No. Yeah. So whenever you select a mate connector on a face, right, the z-axis is facing outwards by default. So if we're extruding the negative z direction, then it'll be cutting in by default, which is helpful. Although we'll add some editing logic eventually that will make that kind of moot. But good to be consistent. Okay. I don't know. We will. I'll leave it as a single direction for now, and I can always add the other direction later if I want to. The difference would be that way you don't really have to specify the direction when you're extruding. I don't know. I don't really have an opinion. I guess I should probably just go both directions. Blind, start, depth, length. It reverses the direction for you. I guess I'll just do both directions for, that way you don't have to worry about direction, which is kind of nice, I suppose. Yeah, okay. So, and that makes this moot as well. Okay, so let's do our transforms now. In order to do our actual transformer, we're going to use OP pattern. Is OP pattern even robust? Oh, it's not even robust. What am I doing? No, OP pattern is not what I want here. Okay, so I do want to do this in a loop. And the reason for that is stability. Basically, whenever you do stuff in a loop, so here we take multiple locations, right? So anytime you take multiple locations like this, you generally want to so basically if you do it iteratively and then you delete the first one, right, what happens is actually I can kind of demonstrate. Well, not really. Okay, whatever. So like if we were to do this naively in a loop, right? So let's say, I'm naively coming along, I want a bearing cutter here, here, and here, right? I select my 3 points. And then I decide, I no longer want this one, right? So if you think about how the code iterates over this list, right? What happens is, whatever I had mated to my second one and my third one, right? When I delete my first one, right? Or actually, so like whatever I had mated to my first one, when it gets deleted, right? The identity now shifts to the second one, right? So when I delete this, right, now this is number 1 and this is number 2 and number 3 is gone, right? So if I had a bearing mated to number 1 in the assembly, right, I had a bearing mated to number 1, number 2, and number 3, right? When I delete number 1, right, now this is my new number 1, this is my new number 2, and so the bearing that was mated over here in the assembly is actually going to jump over here, and the one that was mated here is going to jump over here, and the one that was mated here is going to break, right? And so intuitively you can see like that's not good behavior at all, right? That's pretty bad actually. So we don't want that. So we're not going to do that. Instead, we are going to, we're not going to do that basically. So instead, the way we can fix that is we can associate, instead of just iterating naively over our array and bearing hat here, here, and here, right? We can instead think a little smarter about it and associate, whatever we put here with this selection, right? So whatever vertex the user has selected, right? We're going to associate with that. So when you delete that one, when you delete whatever you had selected first, right? It realizes, oh, this bearing was associated with this selection, that's still there, so we're happy. This bearing was associated with this selection, it's still there, we're happy. This first one is gone, so we're going to break. Nothing we can do about that. But it's not going to shift or jump around on you. So that's what the, there's some stability functions in the library we're going to use to take care of that for us. But yeah, so I am going to loop over my queries. So for plane in planes, right? Yeah, so I'm going to loop over my planes, right? I could pattern. Can't I? No, yeah, I'd have to pattern copy each time in a loop, which is cringe. I'm not going to do that. So yeah, so instead of sketching on an arbitrary plane, I'm going to sketch on the plane the user has entered, right? And then instead of sketching in an arbitrary direction, I'm going to extrude along the negative plane.normal, right? So a plane is a geometrical construct, right? And a plane, right? So if you look at the actual type, right, in the documentation, right, a plane has an origin, a normal, and an x, right? And so those have the geometrical meanings. So here the plane.normal is going to be the direction, you know, the user has selected. Or that'll be the normal of the sketch plane, right? And so intuitively, right, if you think about selecting sketch points and the way you usually want holes to go from a point you selected on a sketch plane, it makes sense, basically. Yeah, so we'll extrude all of those, right? At the very end, we're going to do a Boolean, right? ID plus Boolean, right? And then this is going to be a subtraction, right? And that means we're also going to need targets. And so our tools, so our targets is just going to be our definition.scope, right? And our tools are going to be everything created by, we'll do that. And then I'm going to make a new ID for this, right? So IDs are actually hierarchical, yeah. Classical ID equals ID plus whole tool. Right, so I'm going to make a new ID, and then what I can actually do is I can, so this is where the stabilization comes in, right? So const, tool, let's see here, it's been a little while since I've done this. Unstable ID component, yeah. So this unstable ID component, which is just going to be the index, right? Is this syntax right? Is it the first one or the second one? I guess we'll find out shortly. But yeah, so there's fancy loop syntax. I can loop over everything in an array, and I can also get the index while I'm doing it. I want to say it's like that. I'm not sure. But basically, this unstable ID component is going to be the secret sauce that makes our that allows us to associate it with. And then we can associate this unstable ID component with our selection by doing, what is it called? Robust? No. Let me check the documentation. I've completely forgotten. Unstable ID component. Yeah. ID. What is it called? I'm totally blanking. To be fair, it has been a while. Alright, let's go look at the source code for each entity. Because I know it's in here. And I could also just use for each entity. It's not really a reason I'm not doing it. Yeah, set external disambiguation, that's right. So set external disambiguation is how, instead of using array order, I associate it. So I'm going to pass it in my ID with my unstable ID component. And I'm going to pass in the location I want to use. So here, right, locations is my query array, and then I'm going to index it, right? So locations is what was returned by verify non-empty query, right? So this is associating this whole ID with that specific location, right? And so now I just go through and I use this ID instead of my sketch to preserve the rule of IDs, right? And this could actually even be, no, because it's for each plane, right? But yeah, so now I can use this tool ID, right? So because every hole ID is inheriting from tool ID, right? If you think about like a hierarchical structure, right? If this is the root of the tree, then all of these hole IDs are going to be, branching from tool ID, right? So if I get everything created by tool ID, that will traverse the tree. So I also grab everything. So basically that ends up resulting in all of these things. And then I just want the solid bodies, right? So I'm going to filter down to solids. Yeah, so there's my Boolean, right? And so now, let's see what we got here. Got an error, extrude, okay. Let's see, oh, yep, that would do it. Got to update that. Hole ID there, Humpty Dum, hole empty scope. Yeah, so there we can see our bearing holes. So ta-da, we did it. So we can see we still have sketches coming in. We don't want that. So I'm going to clean those up. And that's just a simple OP delete bodies. ID plus cleanup, right? And I'm going to do Q created by, once again, tool ID. And then I might do Q sketch filter, sketch object.yes, right? So this will delete all sketches, basically, right? In my tool ID, right? Yeah, so we'll do that. And ta-da, bearing holes, right? So yeah, so you select your holes, you select your hats, and it cuts bearing holes. Okay, so I think I'm happy with that. Obviously, there's more features and functionality I need to add. We need a way to be able to more reliably orient these, so we're not just relying on the X direction, especially for like sketch points. You need to be able to specify what angle. So probably gonna have to add an angle parameter. Probably gonna have to specify a fit for the actual bearing hole as well. Because people are not just gonna want 1.125 inches every time. And maybe we don't even cut the main hole. Maybe we just cut the mounting holes. I'm not actually 100% sure how I want to do it yet. But you can see the gist of the features there. And this is something that you could reasonably go out and use, especially if you're just using like the make connector node. Not being able to set the direction is pretty bad, but yeah. Anyway, yeah, so I'm gonna leave off there. This is probably more technical than I wanted, but it was fairly to the point, hopefully, and hopefully you learned something. Yeah.